Today we are discussing about the software quality process. A software quality can be defined as an effective software process applied in a manner that create a useful product that provide measurable value for those who produce it and those who use it. And the definition serves to emphasize the three important points. First one is the effective software process. An effective software process establish the infrastructure that support any effort at building a high quality software product. The management aspects of process create the check and balance that help avoid project shows a key contributor to poor quality. The software engineering practices allow the developer to analyze the problem and design a solved solution, both critical to building high quality software. Finally, an umbrella activities such as change management and technical review have as much to do with quality as any other part of software engineering practices. Next one is the useful product. And a useful product deliver the content, function, and features that the end user desires. But as important, it delivers this asset in a reliable, error-free way. A useful product always satisfies those requirements that have been explicitly stated by stakeholders. In addition, it satisfies a set of implicit requirements, example ease of use, that are expected of all high quality softwares. Third one is adding value. By adding value for both the producer and user of a software product, high quality software provide benefit for the software organization and the end user community. A software organization gains added value because high quality software requirements less maintenance effort, fewer bug fixes, and reduced customer supports. The user community gain added value because the application provide a useful capability in a way that expedites some business processes. So the end result is greater software product revenue, better profitability when an application support a business process and also improve the availability of information that is crucial for the business. Next, we can discuss about the Garvin's quality dimensions. Uh, Garvin suggests that quality should be considered by taking a multi-dimensional viewpoints that begins with an assessment of conformance and terminates with a transcendental view or aesthetic view. Here we discussing performance quality. Does the software deliver all content functions and features that are specified as the part of the requirement model in a way that provide a value to the end user? Or feature quality, does the software provide the features that surprise and delight first time end users? And next one is the reliability. Does the software deliver all the features and capability without failure? Is it available when it is needed? Or does it deliver functionality that is error free? And conformance, does the software conform to local and external software standards that are relevant to this application? Does it conform to de facto design and coding conventions? For example, does the user interface conform to accepted design rule for the menu selector or data input? Next, is talking about the durability. It measures the length of time that product perform uh, before the replacement became necessary. For example, the durability of home appliances such as washing machine can be ranged from 10 to 15 years. Next one is the serviceability. Can the software be maintained or corrected in an acceptability short time period? Can support staff acquire all the information they need to make changes or correct defect? Next one is the aesthetic. An aesthetic effect of a product is comparatively subjective in nature and refer to its impact on the human sense, such as how it looks, feels, sound, taste, and so on. Depending upon the type of product, automobile companies make sure that in addition to functional quality, the automobiles are also aesthetically attractive. Next one is the perception and quality improvement. Dimension of quality is the perception of the quality of the product in the mind of the consumer. Honda cars, Sony Walkman, and Rolex watches are perceived to be high quality item by the customers. Next one is the MSCOL's quality factor. MSCOL, Richard and Walters propose a useful categorization of factors that affect the software quality. The software quality factor shown this figure focus on three important aspects of the software product. It is operational characteristic, its ability to undergo changes, and the adaptability to new environment. These are the three factors: product revision, product transition, and product operation. Okay, we can define those things. First one is the correctness, the extent to which a program satisfies a specification fulfills the user's mission objective. Next one is the reliability, the extent to which a program can be expected to perform its intended function with a required precision. Third one is the efficiency, the amount of computing resources and code required by the program to perform a function. Fourth one is the integrity, the extent to which access to software or data by unauthorized person can be controlled. Fifth one is the usability, the effort required to learn, operate, prepare, input, and interpret output of a program. Sixth one is the maintainability, the effort required to locate and fix an error in an operational program. Seventh one is the testability, the effort required to test a program to ensure that to perform its intended function. Eighth one is a flexibility, the effort required to modify an operational program. Ninth one is the portability, the effort required to transfer a program from one hardware and its software environment to another. Tenth one is the reusability, the extent to which a program can be reused in other applications. 11th one is the interoperability, the effort required to couple one system with another. These are the 10 MCQuad's quality factors defined by them, and ISO 9126 quality factor. The ISO 9126 standard was developed as an attempt to identify the key quality attribute for computer software. The standard identifies 6 key quality attributes. These are the functionality, reliability, usability, efficiency, maintainability, and profitability. These are defined here. Functionality, the capability of a software product to provide a functions which meet stated and implied need when the software is used under specified condition. Second one is the reliability, the capability of a software product to maintain a specific level to performance when used under a specified condition. Usability, the capability of a software product to be understood, learned, used, and be attractive to the user when used under a specified condition. Fourth one is the efficiency, the capability of a software product to provide appropriate performance relative to the amount of resources used under the state condition. Fifth one is the maintainability, the capability of a software product to be modified. Modification may be include correction, improvement, or adaptation of the software to change the in environment and in requirement and function specification. Sixth one is the portability, the capability of a software product to be transferred from one environment to another. These are the ISO scheme is hierarchical. Each subcategory related to exactly one characteristic, external and internal quality. One is the functionality, reliability, usability, efficiency, maintainability, and portability. These are subcategories of each of these categories. And what is a software quality dilemma? If you produce a software system that has a terrible quality, you lose because no one will want to buy it. If on the other hand you spend infinite time, extremely large effort, and huge sum of money to build an absolutely perfect piece of software, then it's going to take so long to complete and it will be so expensive to produce that you will be out of a business anyway. Either you missed the market window or you simply exhausted all your resources. So people in industry try to get to that magical middle ground where the product is good enough not be rejected right away, such as during evolution, but also not to object of so much perfectionism and so much work that it would take too long or cost too much to complete. Good enough software. What is a good enough software? Good enough software deliver high quality functions and features that end users deserve, but at the same time it deliver other more obscure or specialized functions and features that contain known bugs. Arguments against good enough can be, it is true that good enough may work in some application domains and for a few major software companies. After all, if a company has a large marketing budget and can convince enough people to buy version 1.0, it has succeeded in locking them in. If you work for a small company, be wary of this philosophy. If you deliver a good enough or buggy product, you risk permanent damage to your company's reputation. You may never get a chance to deliver a version of 2.0 because bad buzz may cause your sale to plummet and your company to fold. And the cost of quality include all the costs incurred in the pursuit of quality or a performing quality related activities and the downstream cost of lack of quality. These are the prevention cost include quality planning, formal technical review, test equipment training. Next one is the internal failure cost include rework, repair, failure mode analysis, and third external failure costs are complaints resolution, product return and replacement, headline support, and warranty work. And negligence and liability. The story is all too common. A government or corporate entity hires a major software developer or consulting company to analyzing requirements and then design and construct a software-based system to support some major activities. The system might support a major cooperative function, like example pension management or some governmental function like health administration or homeland security. Work began with the best of the intention on both sides, but by the time the system is delivered, things have gone bad. The system is late, failed to deliver desired features and function, is error prone, and does not meet with the customer approval. Then called chain security. The software security related entirely and completely to quality. You must think about security, reliability, availability, dependability at the beginning in the design, architecture, test, and coding phases, all through the software lifecycle or process. Even people aware of the software security problem have focused on late lifecycle stuff. The earlier you find a software problem, the better. And there are two kinds of software problem. One is bug, which is implemented problem. The other is software flow architectural problem is the design. People pay too much attention to bugs, not enough on flaws. Next is the achieving software quality. Software quality does not just appear, it is the result of good project management and solid software engineering practices. Management and practices are applied within the context of four broad activities that help a software team achieve high software quality. First one is the the software engineering method, project management technique, and quality control action. Last one is the software quality assurance. Okay, software engineering methods and project management techniques, quality control and quality assurance, the four things of achieving software quality. Uh, Next one is the software quality assurance. And what is the software quality assurance? It's an umbrella activity that is applied throughout the software process. It is a quality management approach and effective software engineering technology, formal technical review, multi-tier testing strategy, control of software documentation and changing made to it, and procedure to ensure compliance with the software development standards, measurement and reporting mechanism. These are the element of software quality assurance. First one, there are 10 elements of software quality assurance that following manner. First one is the standard review and audit, testing, error or defect collection and analysis, change management, education, vendor management, security management, safety, and the last one is the risk management. These are the elements, and we can define what is a standard. A job of software quality assurance is to ensure that standard that may be adopted are followed and that all work product conform to them. Review and audit, technical review or quality control activity. Their intent is to uncover error. Next one is the audit, that a type of review performed by software quality assurance personnel with the intent to ensuring that quality guidelines are being followed for software engineering work. Third one is the job of software quality assurance is to ensure that testing is properly planned and effectively conducted so that it has the highest likelihood of achieving its primary goal. Fourth one is the error or defect collection and analysis. It collect software quality assurance collect and analyze error and defect data to better understand how errors are introduced and what software engineering activities are best suited to eliminate them. Fifth one is the change management. Software quality and ensure that adequate change management practices have been instituted. Uh, Sixth one is the education. The software quality organization take a lead in software process improvement and key proponent and a sponsor of educational program. Seventh one is the vendor management. A job of a software quality assurance organization is to ensure that highly quality software result by suggesting specific quality practices that the vendor should follow when possible. The incorporating quality mandate as a part of any contract with an external vendor. Eight one is the security management. Software quality ensure that appropriate process and technology are used to achieve software security. Nine one is the safety. Software quality assurance may be responsible for assessing the impact of software failure and for initiating those steps required to reduce risk. Then the one is risk management. Although the analysis and mitigation of risk is the concern of the software engineers, the software quality organization ensure that risk management activities are properly conducted and that risk-related contingency plan have been established. Okay, these are the main 10 elements of software quality assurance. Okay.